One question I was asked recently is, how do you take the time course of some tissue class? Like, for example, white matter, CSF, in general stuff you're not that interested in, and use it as a covariate to get rid of that variance in your model. Well, there are a couple different ways you can do this. The tool I'm going to use right now is a new one. I haven't talked about it before. It's 3D Seg for segmentation. Now, that's the first step you need to do to actually get the time course from those tissue classes. Obviously, you could do something else. You could extract those same tissue classes with something like one of FSL's commands with free surfers for much more precise segmentation, but not necessarily as fast. 3D Seg is more quick and dirty. It takes about 20-30 seconds to do. So, if you're going to use that, just a little caveat, it's not super precise, but for your purposes, maybe it's what you want. What I've done here is I've already run 3D Seg. Once you do that, you are left with a folder called seg sy. 3D Seg is very simple. It's just 3D Seg anat and then your anatomical image. In this case, could be MP-RAGE. If you don't want to deal with normalized brain images, you want to do it each person individually, do it with an unnormalized anatomical, but it really depends on your question. So I've already done it. Really, this is the only stuff you put in the command. There are other options as well. You can get posterior estimates for each class, tissue class, but we're not going to go into that right now. So I'm going to go in here into this segmentation folder, and I'm most interested in this classes plus TallyRack dataset. So I'm going to leave as the underlay my anatomical, overlay the classes, and notice here that these are color-coded differently. So if you look right here, notice that 3 represents white matter. The label is WM, and it also has a 3. CSF is a 1, and everything in purple is 2, and that's gray matter. So if I wanted to separate all those out individually, I could just use 3D Calc. A is going to be my classes data set, and the expression is going to be a mathematical expression, and I'm going to use equals, and where in this classes data set, represented by A, is there 1. And remember, 1 represented, I believe, the CSF, so we're going to call this CSF. Okay, I could do the same thing for gray matter. Remember, that was 2. And also white matter. And here that was 3. So if I look at this all again, these new things that I just made, white matter is now going to be everything that I just extracted. Gray matter, likewise over here, and CSF, everything else. Right. So let's say we just wanted to take the time course, the average time course for each time point across all white matter, and use that as a regressor in our GLM. First, I'm going to copy those white matter data sets up above one level. And now, little thing here, I got to resample that to match the grid of whatever I'm trying to look at. So, for example, this is the same data set I've used a lot of times. It's this online Kennedy Krieger Institute data set, and this deals with arresting state data set, right? So I have this ARTS, which represents just all the resting state stuff with motion confounds removed. So the master is going to be that AR.ts data set, and the inset is going to be white matter, and the prefix, I'm going to call the output WM resampled. Yes. So once I have that, I can use 3D mask av. I use the quiet command because I don't want that, just want each time point for each value for each time point. And we're going to have here the mask is going to be AR.ts. And the mask is going to be this resampled white matter mask. So that's what we're only interested in. And do that for this AR.ts data set. And notice that if I just do that, I get a bunch of values. I can do this with 1D plot just to make sure that it looks somewhat interesting. 1D plot with the std in command. And yeah, this looks like a time course that I would expect to see in a typical fMRI data set. Now all I need to do is just take those values, put them into a 1D file just like that. And now when you use 3D deconvolve, you can use that with the stim files command to insert that directly into the GLM without convolving it. So hope this helps. Again, this really depends on what questions you're trying to answer, and that depends on what tools you want to use. You can either use AFNI 3D Seg, quick and dirty, or you can use something longer but more precise like FreeSurfer's automatic segmentation tool.